Morning guys, I hope niyaphila. Sizokwenza question 1 on this series. So the first part question 1 for electrotechnics N6 is its speed control calculations of DC machines. Okay, so what I'm gonna do, I'm gonna first write you the formulas. We're only gonna do calculations. I'm gonna write down the formulas that we'll be using. Then can go explain the formulas. Then we start looking at question papers. So the first two formulas that are very important in this calculation, Elena, E1 over E2 is equals to flux 1 N1 over flux 2 N2. Okay, so guys, the motor lena is operating under two different conditions. London Pale 1 E1 E2 yabo, flux 1 flux 2 N1 N2. Okay, for example, ngathiwa le motor ibine EMF engaka, ibine back EMF engaka, yachinja ke ngoku back EMF yayile value, or yachinja flux yayile value. So E1 is back EMF of first condition. Then E2 is a back EMF of a second condition. Then we have flux 1, a flux of a first condition. Okay, then flux 2, a flux, okay, of a second condition. Okay guys, then the EMF guys iyakwazi uchinjwa. Okay, what do I mean iyakwazi uchinjwa? This part of flux uyakwazi ufaka intoni i-field current. What do I mean? E1 can be E1 over E2 is equals to I field 1, yabo? Then N1 I field 2. Yabona in place of a flux, I'm putting him a field current. Yabo? If a series motor, a series field current. If a shunt motor, a shunt field current. But there is a condition. If a question is unsaturated, then we can, in place of a flux, we can put a field current. Unsaturated or mati, the field strength, and funupala or mati, the field strength is directly proportional to a field current. Okay. Then another important formula says we say torque, whereby it says T1 over T2 is equals to flux 1 is equals to flux 1 I amateur 1, flux 2, I amateur 2. Okay, so iyazicacela ke guys. T1 yintoni? I-torque first condition. Then T2 yintoni? I-torque second condition. Okay. Then IA1 yintoni? Armature current first condition. Okay. Then IA2 armature current second condition. So on and so on. So guys, with the same thing that we can do with torque, the same thing that we did with torque EMF, we can do it with formula the same thing that we did with formula EMF, we can do now with formula torque, whereby in place of a flux we can put a field current, but ke ngoku mele impithe the condition that singathi T1 over T2 is equals to flux 1 is equals to I field 1 I armature 1 over I field 2 I armature 2. This only applies, same thing, this only applies when you are told that if unsaturated condition, field it is unsaturated, or if flux is directly proportional to a field current. Okay, those are the two equations. Okay, the first, those are the two equations that we'll be using extensively with calculation. Nansi yokuqala, then esibini yintoni? Torque. Okay, then ke ngoku enye equation that we'll be using extensively, suppose in T3, ilena here, back EMF. A back EMF motor is given by E is equals to V minus IA RAC. Okay, whereby E must ila back EMF. Yabo, back EMF. Okay, xhomekeka bangu E1 or E2. Yabo, for example, the formula I change E1 IA1. Yabo, ka ufuna E2, same formula, V minus IA2 RAC. Okay, then O V and yintoni is supplied or applied voltage. Okay, then OIA must yintoni? The armature current. Okay, then RAC, guys, RAC ayo armature resistance. RAC the armature circuit resistance. Uzoyibona le nto ndithetha ngayo, the armature circuit resistance. When we do a calculation, armature circuit resistance, basically total resistance ekwi armature circuit. Okay, okay, the next thing there'll be two types. There are two types of motor whereby we'll be performing these calculations now. It can be For example, a question can ask you in series mode. So Kalapa series mode. Okay. Question can ask you about a series mode. Yeah. Okay. Let us draw a series mode here too. Okay. Okay. Okay, there's my series motor. Okay. With series motor, guys, we have OI load osuka from the source. And there's been I series. And there's been no I bani, I amach. Okay. Of which is with series motor, we can see that OI load is equals to I series is equals to I amach. Because, guys, this is the series circuit. Yeah, this is current flowing in only just one loop. The current is only flowing in this loop. I split IST. Yeah, okay. Then singalibali ke ngokuba a field winding in a resistance R series, then armature now in a resistance RA. Okay, of which is kasifuna e-back EMF, the formula applies. E is equals to V minus I A RAC, and of which is E1 a first condition, then armature current a first condition. Kasifuna E2 is equals to V minus IA for the second condition. And ORAC, guys, upper ORAC indoni take total armature circuit resistance. Okay, if siyabona ziyi-2 i-resistors ezilapha kwi-armature circuit. Yeyiphi armature circuit? Nansi yiyo yonke le armature circuit le, whereby there is an armature connected in that loop. And zeziphi ezi-2 resistance ndithetha ngazo? Nazi i-resistance series winding ne-armature, they are connected in series. So the total resistance of the circuit, which is RAC, is equals to R series plus R armature. Okay. Then any circuit ongayinikwa ke ngoku is circuit, yes, yeah, the circuit to increase its speed. For example, what do I mean? To increase, increasing a circuit to increasing its speed. Says series mode. Okay. What we do here is that, okay. If we want to increase a speed, and to draw a circuit to increase the speed of a series motor. This is the circuit that you're gonna draw. You just put a variable resistor in parallel with the series field winding. Okay, of which is, okay, current is now I load, and ibe ngu I series, and then ibe la current ka I diverter current, then ibe armature current. Upper we can no longer say I load is equals to I series is equals to I armature. This is wrong, guys. This is This is wrong because apha ke ngoku problem is that current yathini iyasplita phaa kulaa junction yabo. Okay, iyasplita, so we can no longer use this statement yabo. Into yethu iyatshintsha nje kancinci, itshintshela to intoni ngoba u-I load, yabona I load yena no I amateur bayalingana yabo, but abalingani no I series because i-current ku-I series i-current esplitiweyo, i-current etheni, i-current flower up yabo, i-current etheni esplitiweyo, yena. So if usifuna R series or I series, we can use a current divider rule. Yena, i-current divider rule singathi enye formula ke ngoku esizoyisebenzisa, but for le circuit your increase the speed se-series mode, I series is equals to R resistance diverter, R series plus R resistance diverter times OIA yabo, or you can say times OI load, since OIA no I load belingana. Okay, then ke ngoku another sorry, let me go to the next page. Another circuit esinoyinikwa kwi-series circuit is circuit to reduce speed, reducing speed of a DC, of a series mode. Okay, what they do ne, how reduce the speed say series motor, you connect a resistor in series with the armature circuit. Okay, you add a resistor in series. Okay, this is the circuit that you're gonna draw. Okay, okay, so your resistance or connected in series level maybe so RX, then maybe resistance series winding, maybe resistance armature. Okay, I load, I series, okay, I armature. If siyabona again upper guys, current I split, so we can safely say I load is equals to I series is equals to I armature. The only difference is that is the way you're gonna calculate OR or RAC. Or RAC ngoku uzoba ngubani? Izoba ngu RX, because kaloku remember le resistor is connected in series nayo yonke lento, so now it's part of the armature circuit, plus R series plus R armature, because RAC kaloku remember simsebenzisa xa sifuna i-back EMF. No? Okay, cela ubuyela back ke ngondilibele nakweli cala. U-RAC kule case le kule case lena your increase the speed se DC series motor is equals to, remember sinantoni apha, sine parallel circuit that is in series nale armature. So qala sibale the parallel combination, you can use a product rule, product over sum rule, yeah? RT times R series, RT plus R series then sizo-add ke ngu-R A. Yabo. Okay guys, we're gonna do a question ethetha nge-series motor now. Nibone about how we perform these calculations using those formulas that I did show and explain to you guys. Okay, so I'm gonna start with question 4. It says a 300 volts DC series motor. So it's important to note what type of motor it is. Yeah, because remember, logo, the way we analyze other type, like the way we analyze the series motor, I find the way we analyze I find the way we analyze a shunt motor. Runs at 1000 revs per minute. Highlight that. Okay, N1. When drawing 42 amps from the supply. Okay. The resistances of the series field and armature are 0.3 ohms and 0.225 ohms respectively. And if a resistor is connected in series to the field coil, remember this now. If the resistor is connected in series with the field coil, so that the speed of the motor drops to 750. But remember, when we want to reduce, I've showed you, when we want to reduce a speed with series motor, we connect a resistor in series. Okay. For example, let me go back here. Reducing a reducing the speed of a series motor, we connect a resistor in what? In series. Then when we are increasing a speed, we connect a resistor in parallel with the field coil. Hence again, the question bayasibonisa ba okay, xa bese connect a resistor in series with the field coil, the speed says a drop to this value. Okay, now they want us to calculate the resistance of the resistor. Okay, what that actually means, guys, but if resistance, but le resistance ne yalapha mele ibe ngubani, so that speed is drop to la 750 revs per minute. Baminisha loo nto apha uba basibali ba mele ibe ngubani le resistor, so that speed is drop from 1000 to 750 revs per minute. Okay, but assume the load torque is proportional to the speed. Okay, a load torque is proportional to the speed. That's what we should assume. Then also assume a straight line magnetization curve. A straight line magnetization curve, guys, it simply means unsaturated. It means that, let me draw this. Okay, it means that Nancy field strength Nancy a field current. It means that if a field current increases, the field strength increases, meaning which flux is directly proportional to a series field current. Okay, so we need Tina o calculator ubani we need to calculate we need to calculate a resistance. Resistor. So go first condition. Let me draw a circuit here. First condition. Okay, Okay. Okay. With first condition, i-circuit yami ibinje, ne? Okay, ibinje. And the supply yobani u-300 volts. I-current is IL ingubani 42 amps. Okay, let's say IL1. Okay, because it's the first condition. Or IL1 is equals to 42 amps. And if we say the circuit, IL1 is equals to I series 1 is also equals to I armature 1, because upper a current I split. I split. There's no junction. It's only just one loop. Okay. As signing again the resistance series field winding. Okay, which is R series, and now it as O 0.3 ohms. Signing again the resistance armature. Armature ubani 0.25 ohms. Okay, of which is, guys, if we see a the circuit, RAC is equals to R series plus RA. Miyabona mos. Nanso RA series RA. Yabo. Zizoqha ezikhoyo ku-amateur circuit. But sithrowe ke ngoku kwi-second condition. Second condition. Okay. 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 The voltage man 300 volts. If voltage abachong be change. If voltage I change wanga or any supply voltage, that means you're still having the same voltage across. Basibize le resistor ile ifunwayo. Basibize ngobani ko RX. Yabona, of which is if siyabona apha ne u RAC mandithi RAC2 ana, let's say this one is RAC1. Ku RAC2 siyabona ba okay, RAC2 yena ko RX ane lo simfunayo plus OR series plus OR armature. Okay, armature. Okay, of which, guys, this is what we wanting. Yabo, but ke ngoku kuze sikwazi sinayo lena but sidinga lena ne RAC2 babi E2 V minus IA2 and RAC2. So that means kan funa RAC2 mele ndibale ubani u-E2 ne amateur current bangibani. Okay, so ilento sizoyenza ke ngoku. U-E2 singamfumana njani? Singamsebenzisa le formula E1 over E2 is equals to flux 1 N1 flux 2 N2. Okay, guys, if siyabona asinayo kwa i-field, asinayo i-flux, akho nto esinikiweyo ye-flux ekuthiwa 0 point something wepas, yabo. But ke what we can do, we can analyze that, because remember, but a straight magnetization curve, meaning if flux is directly proportional to its series field current, of which is Since again kunjalo, if flux is proportional to a series field current, okay, and that means that E1 we can put the second equation in place of flux yakwazi ukuba kufake field current. So I series 1 N1, I series 2, and ibanjalo in most cases when you are dealing with a series motor, because with series motor, if a current ehamba kwe-armature increase, basically since they said they carry the same current as the field winding, ne magnetic field iyachinja, yabo. Kwi-shunt you would see that most of the time if field strength is constant. Okay, so the first thing we can calculate for now is E1. E1, okay, is equals to, sorry, let me use red color for a first condition. E1 is equals to V minus I1 RAC1. Okay, UV wethu ngu 300, okay, then minus I armature, remember kule condition a current esuka kwe load kwe source iyalingana no I armature, yebo. Hence again ndizofaka bani u42, then open brackets, RAC we-add intoni i-series field resistance ne-armature resistance, which is i-series field resistance besithi ngu 0.3 plus then armature resistance is 0.25, and then ke sizofumana E1. Let's punch that on our calculator. 300 minus open brackets 42 close bracket 0.3 plus 0.25. So if voltage to back EMF, first condition is 276.9 volts. Okay. Apha into sifunayo sifuna ubala bani? Sifuna ubala le u-E2 because ayazi ba izosinceda ba sifumane bani? Sifumane RAC2 so that sizokwazi ubala bani u-RX. Okay. Fine. Okay. Dikhumbule ke ngoku dinayo le current I series 1 bani? I series 1 it's 42 amps. Remember, a current up I split mos kule first condition. Ana dinaso speed. Okay. Into nenye dinayo i-speed sesibini. Into endishota ngayo ukuze ndifumane ubani u-E2 intoni i-series field current yesibini. Intoni i-series field current yethu yesibini. Okay, means guys we have to try and find I series 2 so that sizokhangela u-E2. Yabo. Okay, a statement best assume that a load torque OT is proportional to intoni a speed. Okay, or meaning which if a speed siya increase, then a torque increase. Okay, if a speed siya decrease, a torque decrease, of which is in this case for the calculation a speed decreased. So a speed decreased from 1000 to 750. Okay, meaning which T2 sorry, meaning N2 ne speed singu, if you want to calculate it singu bani uzothi 750 over 1000 times 100. Uzobona ngoba speed singu 75% compared to n bani n1. Okay, speed sesa reducer sangu 75% of speed ska n1, meaning torque T2 is 75% T1, meaning it's 0.75 T1. Okay, loo nto leyo izosinceda sithini sicalculate le current. Remember i-formula ye-torque benthe is T1 over T2 is equals to flux 1 I armature 1, okay, flux 2 I armature 2, okay, of which is apha ke ngoku kube sithe if field strength is proportional to a field current. That means a formula yethu ke ngoku siyibhala T1 T2 I series 1 I A1, yeah? Then I series 2 lo simfunayo I A2, okay, I A2, okay. Sikhumbule ke another thing is that I series 2 no I armature 2, they are the same, and same I splitanga nalapha yabo. Hence ke ngizothi kandibhala, okay, T1 they substitute ke ngoku T2 yana nanku ne ku 0.75 T1, 0.75 T1, then upper I series bani 1 is equals to I armature 1 basiyibotsho nansi up le circuit mos, so I can say upper 42 squared, then upper I can say I series 2 squared because the current lena lingana. Go multiply into ezilinganayo mos. If I'm saying 2 multiplied by 2, it's the same as saying 2 to the power 2. Okay, and now we can calculate ubani I series 2 ezi ziyakhansilishana mos na. Okay, because ndibeke T2 in terms of T1. Okay, so that means I series 2, okay, sibalalena is equals to square root, since it's not square obvious, so by square root 42 squared 0.75, then sifumane I series 2. Let me just punch with calculator. So the current rate is about 36,373 amps. Now we have calculated, now that we have calculated Nalena, we can find money E2 by using this equation, of which is E2 is gonna be Okay. Sorry. E1. Okay. I series 2 and 2. I'm just making E2 subject of the formula here, guys. I couldn't enzima maskamnandi. You have a mathematical background. I series 1 and 1. Okay, E2 would be I series 2 ngubani siqhubambala ku 36 comma 373 times n2 ngubani ku 715 reals per minute. Then I series 1 42 times n1 kubani ku 1000. Okay, this is of money E2. Over 42 times 1000. Sorry. 36,373 times 750. Times E1 way to times E1. Lo E1 must is on multiplier upper and it E1 way to best bani. E1 way to best bani onango 276,9. Okay. 42 times 1000. Okay, times 276,9. So back EMF here to it to 179,851 volts. Okay, guys, we have calculated E2. Now we can calculate OI bani. OI. Now we can calculate ORAC2. Okay, but a substitute again. The formula. Since OI AC2 subject of the formula. Okay, we took 179, 179,851 is equals to OV way to 300. Okay. Then UI amateur 2, remember, a current iyalingana nala. Yabo. OI series 2 is equals to I amateur 2. So OI series 2 best ngubani ku 36,373. Sorry. Yeah. Then being RAC2. Okay. So kasibalo RAC2 so fumana bani. And until let's say I transpose izoba 179,851 minus 300 over 36,373. RAC2 minus now. So we are dividing by negative upper, sorry. It was determined to and from a negative value. The resistance, guys, as I care negative. So bekumele 10 negative 36,73 because there's that negative. Okay. 851 minus 300 divided by negative 36,373. It is resistance yapana ku 3,303 ohms asikaqebi, and it is taken RAC 2 is RX plus R series plus R armature, okay, of which is RAC 2 simbalile ngu 3,303, then RX, then R series kubani ku 0,3 plus R armature is 0,25. Okay, then that means RX is equals to 3,303 minus 0,3 plus 0,2 25. Okay, let's calculate that. 3,30 minus 0,3 minus 0, make me minus okay, 0,25. That means a resistance as me see at upper is 2,753 ohms. Okay, guys, this is where I'm gonna stop with calculations. It's a series motor. I want you guys to attempt these two, and then after attempting, then parallel on the comment section, then I will do a video on these two specially for as a correction. I just want to allow you guys to ni practice, yabo, and aban batitsha college tina sizozenza correction eklasini.